Let's now do an example of a non-variable force and, or not a non-variable, but a non-constant force, a variable force, and determine how to calculate the work done by that force between 2 points. So let's say that if I have a displacement versus force graph, that I have a force that is quadratic in displacement, okay? Now this is a fictional force, I don't know what this might look like, but let's just say that as my particle is moving along in the x direction, the force is getting larger and larger and larger and larger, okay? So this might be an attractive force of some kind if it starts away from a certain object and it gets closer and closer to that object, and the force goes up and up and up, all right? Whatever the case may be, let's say that the force is equal to some coefficient alpha times x squared, okay? And I want to know what the work is between these 2 points, xi, and say this point right up here, xf, right? So how do I calculate the work done in this situation? Well, first of all, what is the work done going to represent? Remember that an integral represents the area under a curve. So the area under this curve between these 2 points represents the work, okay? That represents the work. So if I want to calculate this, the work, and we're moving in one dimension, right? We're just pushing an object along, but the force is gathering strength as we move. So this is going to be xi, xf, f dx, okay? So if I carry this integration out, xi, xf, I get alpha x squared dx, and my alpha is going to come out of the integral since it's a proportionality constant, and the integral of x squared is 1/3 x cubed. So this is going to be alpha over 3 times x cubed, and that's going to be from xi to xf. So this would turn into alpha over 3 times the quantity xf cubed minus xi cubed, okay? Now, what if I wanted to know what the final speed was, okay? Again, if I know what my initial speed is here, I know now the work done on my object, I can use the work kinetic energy theorem and say that the work done is equal to the change in kinetic energy. And if I know what this initial velocity is, I can calculate its initial kinetic energy, and then I can calculate the final kinetic energy just the way we did in the previous video. All right, in the next video, I promise we will talk about power.